Good morning. Everybody is always, all the time, searching for something, according to Abraham Maslow. So search and discovery are very central to life, human experience. Let's get started. National Academy of Sciences commissioned a study a few years ago. They asked people like us a question. If we take away the ability for digital search from you for 1 year, what compensation would you like for it? On average, people said $17,530 per year. If they lose email, it's $8,414. And with maps, it's about $4,500 or $3,600. So search is the most important digital capability which we value very highly. There are about 30 trillion web pages in the world. Billions of web searches happen in a given year. Vast volumes of content that Netflix releases and people enjoy. Similarly, many hundreds of hours of video time uploaded to YouTube in short periods of time. So for all these types of modern technological capabilities and also the not-for-profit initiatives like NGOs, service organizations, education, governmental efforts, there as well, the same digital platform service models are becoming more and more prevalent. In all those cases, the global economic value of search and discovery is close to $1 trillion. Each search that we do has 50 cents per search value attached to that. I'm showing 3 models of platforms for these digital experiences. On the left-hand side, you have consumer. On the right-hand side, you have provider, the seller or government service provider. If the platform is proactively pushing information about goods, services, content, that is recommendation. If the users are actively looking for content, searching for content, that is search and discovery. And if there is a platform as a mediator in between, that is an arbiter, MINDBODY's fitness, wellness, beauty platform is an example of that for the fitness and wellness needs of society. Here, on the left-hand side, you see the familiar hierarchy of human needs, Abraham Maslow's hierarchy. And the right-hand side, computer scientists' attempts to translate that into a similar hierarchy for search and discoverability. As people are searching for various goods, services, and experiences up this hierarchy, at the bottom of the pyramid, on the right-hand side, we have safety needs for the products and experiences that we are looking for. Is this product safe to use? Is this service real, and is it okay to use it? And is my privacy protected? Is my reputation at risk if I use it on the digital platform? Considerations of that nature. And then moving up the hierarchy, utility. Will it do what I need this service to do for me? How effective is it going to be? How efficient? Cost effective? Will it save time? And is it going to be a better experience than what I am already using or paying for? How satisfied am I going to be with this experience? And then self-fulfillment needs. There is a strong matching between Maslow's pyramid of needs and this search and discoverability hierarchy. Self-fulfillment, for example, is it fun? Is this experience going to be liked by friends and my network? How am I going to enjoy this with my peers? how satisfying is this going to be to my artistic sensibilities, questions of this nature. What I drew in the middle there is an arrow upwards, that is a search personalization arrow. The point there is, as we move up this hierarchy of goods, services, movies, books, and so on, the higher you're negotiating this pyramid, the stronger the need for personalization is going to be. For example, safety is pretty common to all of us human beings. A safe drinking water source, safe facility, safe transportation. There is not much room for personalization. But a movie, a friendship network, a song that you would like to listen to, experiences of that nature are increasingly, there is an aesthetic involved with it. So to understand the agent which is doing the search, which is the self, providing data structures for its context, its intent, that is at the heart of personalization. That is important for a satisfactory, aesthetically pleasing experience up that hierarchy. MindBody is running technology products and enabling them for the fitness, wellness, beauty industries, and it's a leader in this industry for the past 20 years. Our mission is to help two types of people. The providers who provide fitness, gym, salon, spa, wellness clinics, yoga, and so on, bring their wares, bring their services, classes, trainers to this platform. And on the right-hand side, millions of users, consumers who are searching for better health, better wellness, fitness to discover, pay for, and enjoy those services, classes. I'm showing wellness index that is constructed and published by MindBody periodically for United States currently. It shows the relative wellness ranking of communities, populations through United States. So that is an example of a service that we provide. So for us, a satisfactory, cutting-edge discoverability and search experience is very critical for all the products and platforms that we build, run, and manage. That is why artificial intelligence, machine learning are important. In general, for these types of platforms, both for profit and non-profit as well, digital platforms, search and recommendation via machine learning have become really important. Wellness has those 7 dimensions to it: social, emotional wellness, physical wellness, spiritual, and so forth. It is almost half the size of healthcare industry, which is 1/3 of the whole economy. If people proactively are fit, they take care of their physical and emotional, mental needs better, that eases the burden that we currently place on healthcare industry. About 5% of the whole population consumes close to 50% of all resources within healthcare. About 40% of all healthcare spending goes to inefficiency, fraud, waste, and abuse. So fitness, wellness, these are helpful initiatives that help people not to fall sick so often in the first place. It is active pursuit of physical and mental well-being using the means available. These days, digital and technology means as well. So there's a difference between findability and discoverability. When a person is conducting search, we are familiar with that text box for search. They are either specifically looking for something and they find what they need, or they start with a search string, but it is a conversation on the right-hand side, platform is encouraging the users, helping the users to conduct this interaction with the platform, discover additional things that are related to your general intent of your person. That is for a human being. For example, I type umbrella, and the platform will show me umbrellas, but it will also start showing me hats and hoodies and raincoats, and so on. So there are various aspects to the experience of search. Cognitive scientists, computer scientists studying HCI designers, they say that there are 5 different modes of search: browsing, searching, asking, finding, filtering, and so on. Here's a taxonomy of search technologies. People can be straight up navigating, looking for something: Greyhound bus, Delta Airlines. So that is, you have clarity about what you're looking for, you're searching for that. Or information, you're generally searching for information on a theme or a topic, then the platform needs to be intelligent about who you are, what your intent is, and then guide you toward highly relevant sources of information. So here, when I say information, it is also called document, catalog. That is, any information about the various goods or services that are being provided by the providers, government or digital marketplaces. For example, movies, music, medicine in case of digital pharmacies, healthcare services and treatment options in case of telemedicine, which has become very important. And the usual services we are familiar with: Amazon, goods, Netflix, movies. So all of those can ultimately be, from a computing point of view, cataloged as documents. An item with some images, some content, tags, metadata. Then queries are on the right-hand side. Transactional search and discovery is with the specific intent of buying something, shopping experiences. So the technologies that evolved for this since 2007, 2008, that time frame, are crawler-based or catalog-based hybrid. Crawler-based search and discovery is cataloging something about the URLs that run into trillions a priori. That is what web crawlers or spiders do. And then assign a relevance rank against typical queries and have all that available for query time, for runtime. Then when a query actually happens, look up that against that index for the relevance rank, search the results. So directory-based is human beings are ranking these documents also ahead of time. So as a catalog, taxonomy, say sociology, psychology, and then all the subcategories within that. These days, all popular search engines use a combination of those 2 methods. Then there are meta search engines, so Dogpile, Metacrawler, ensembles of these different search engines, or specifically for travel, Expedia, specifically for domain name search, DNS engines. That this is mostly for the human consumption, but increasingly devices and machines also need search capabilities. There is no case for personalization for machines, but when a router is finding pathfinding in networking, those are search algorithms too. Robotics, robots are something in between. We can foresee that there will be needs of personalization when robots are active and popular. They're searching for something, communicating among one another. So to begin with, search started in information retrieval, IR. There is no machine learning involved here. Documents repository, as I mentioned, D. is a large set of documents, and the query repository, the typical word strings that people use to conduct their queries, is a set Q. Queries are considered documents too. In information retrieval, ultimately a large book or a video or audio or a few word search string, all of them are documents. A document is represented by a set of tokens or words, W1, W2, W3, T1, T2, T3, so on. So the job of a search engine is matchmaking. Take this query, which is a document, these large set of the cataloged assets, services, movies, documents, find the few highly relevant documents for the particular query. This is the problem of search. And the way it is done is look for a relevance rank matching strongly the D set and the Q set, either as a binary 0 or 1. This document matches with the keywords that are here, or it does not, or a probability as well. So that's where it started. Here's a paradigm document vector space model. Documents in a hyperspace represented by the keywords can be placed as a vector within that space. Every document, query is also a document. Here, for example, weight on x-axis, diet on y-axis, 2 keywords. We are trying to match a document with a query. Documents about nutrition will have a lot of words about diet, so they will lean towards the y-axis. Documents about just shipping will have a lot of words about weight, so they'll tilt towards y-axis. And a query, Q, where you're looking for fitness-related documents, could be something in the middle. There are similarity metrics, cosine similarity, and so on, which we can use to mathematically assess which small number of documents are relevant to that particular query. So that is information retrieval. It can be made pretty complex with fuzzy matching, probabilistic record linkage, stemming and tokenization of the query words and document words too, using natural language processing, better efficient indexing methods. With all that, it is still not machine learning. Yes, it's still not machine learning. So what can machine learning and artificial intelligence do for this advanced search engines and discovery that the society is looking for? Personalization is something that can be done. Refining query strings has evolved into an entire science, query understanding, and using machine learning for that. And for performance reasons, because these are very, very large data sets that we are talking about in the large enterprises, there are various pre-processing and post-filtering techniques that all have to do with machine learning and artificial intelligence too. I'll say more about it. So recommendation and search are not the same thing. So people have looked at using recommendation engines for search. Recommenders and personalization was the focus of my talk this past December, also run by ValleyML.ai. There we discussed recommendation and personalization. The reason why you cannot use recommender systems for search engines is their concerns and their capabilities are significantly different. In case of recommender systems, we have problems like cold start, data sparsity, too much data, cursive dimensionality, and the goodness metrics are also somewhat different. In case of search, it is the user initiating the search. So indexing a priori is possible. Then ranking of the relevance is the essence of search. So that's good to keep in mind, because in this practice, all machine learning engineers typically run into, I'm doing recommender systems for my small e-commerce company. I also need search. Can I use the same for both? There are arguments both ways. Now personalization, what is it? So beyond information retrieval, even machine learning based information retrieval, beyond that, an individual consumer or a person is specifically looking for something, and not all of that is included in their query to the chatbot or the text box or speaking to Alexa, Siri, and so on. Only a small part of it made available during query time, during runtime, but there is a whole context and intent to that, and capturing that correctly will help us provide the correct results. Depersonalization is its opposite. It will lead to unpleasant consequences. For example, a popular web platform started sending people who searched for items on their platform a lot of advertisements about getting married, wedding. And that was not the intent of why people were searching for wedding dresses and wedding venues and so on. It's not that they're getting married, it's just that somebody they knew is getting married. So there was a mismatch of intent. So depersonalization. So e-commerce platforms take great care not to do that. So the reasons for personalization are clear from data. Almost 60% of consumers said we will really like it, both public sector and private sector also, if the search is matching our intent. And context is, by Zimmerman, modeled this, and this leads to personalized user profiles. Is who is the person, what is their activity currently, and where are they currently located, yes, which is difficult to glean. What time of the day are they conducting this search, and how are they related to other items and institutions and people. That. So then this modern technology grows into advanced algorithms which use machine learning. Learning to rank, LTR, is one example where you are starting with information retrieval, but you're taking outcomes from multiple algorithms like best match 25, TF-IDF, and so on, making the results from those algorithms as features into a machine learning model, support vector machines typically, and using that to ultimately come up with a rank for the individual query. But businesses are for profit. Even governments, non-profits, they have a currency also. So K-armed bandits or multi-armed bandits, they can optimize this discoverability experience, not only keeping the user's intent alone, but the seller's intent also. They need to be able to sell better conversion, short stock life, and all that. So when you have multiple objectives, not just user's intent as a rank alone, then you use multi-armed bandit algorithms to optimize across those different objectives and still provide a satisfactory search experience. And personalization, finally, it involves three things: representing the person, representing the catalog, machine learning for learning personalized user profiles, and then bringing all that to bear in the final rankings, the relevance rankings. So one way to think about that is it is a search engine that you're using, but you're disciplining what you're displaying for on your SERP, the results page, depending on additional criteria and algorithms to personalize those results. In the interest of time, I will stop here. And if you have any questions or comments, please let me know.
I just want to, I mean, you didn't quite maybe have enough time to finish there, but basically you're using all these techniques in your service to provide better search in these venues you're speaking of.
That is correct, yes. And here is a couple of use cases specific to fitness and wellness. People have increasingly are becoming interested in the idea of fitness, but their life situations are pretty unique and interesting. They live in one location, they work in another location, they travel frequently to other locations. They are looking for gyms or yoga studios or whatever that is they are interested in, not with just one gym in your living place, but multiple places, and how to optimize the pricing and good trainer. All of that is important for fitness experience. That is one example of why this is necessary, the sophistication.
Thank you.
Yeah.
Yeah, I think we still have like 10 minutes for Q&A. You can probably go to your summary slide. You still can take some time.
So this is where I would like to spend that time. The fact that search engines return results from search, this we are familiar with. Using intelligent virtual assistants, chatbots at the bottom corner of typical web stores, this we've also become familiar with. And then using audio-based search with Siri and Alexa, Google, so on. We are familiar with this. So what is it that is extra with discoverability by using personalization? And what are the algorithms of personalization? This is a fascinating question for technologists in the industry, product managers. So what personalization is capturing that context about the person longer term, and also right now during query time, and intent of that person. This is laden with a lot of ambiguity. Simple example, say consider person Dan. Dan purchased some books in the past 1 year, number of books on a bookseller platform. So some of those books he purchased are children's books, Diary of Wimpy Kid, things like that. If the platform is not using personalization algorithms, it will be confused, thinking that Dan likes children's books. Simple example. That's not the case. He was buying those books for his daughter. The books that he's interested in are within that signature, but it's really something else. How do you figure that out ahead of time? That is just one example. And there are various aspects to that persona and context. Capturing all of that longer term and right now, query time also. This is the mission of personalization. The algorithms that are used for personalization start with constructing personalized user profiles, something or a lot of things that you know about the person. And there are privacy concerns associated with that. Then there is implicit and explicit data available for that. Explicit is you're asking the users by survey and other means, what do you like, who you are. And implicit are data that you can get from other platforms, other data vendors about individuals. And data that traces that the individual is living within the platform about what they clicked, what they bought, what they did not buy, how much time did they spend looking at what kind of item, all of that. So pulling those signatures together from query logs, for example, machine learning is used, a priori rule mining, one example of algorithm, to construct these personalized user profiles. Then it informs the search in very different ways. So
quick question is, how do you support interoperability? Because let's say I'm using my mobile phone at home, but then I switch to my car when I'm going to work. At work, I have a totally different setup. So how do you connect the interoperability? Because a platform is dedicated probably to one device versus the other. And part two is, you talked about privacy, but very quickly touched on it. Could you expand on in the era of people being more aware of privacy, knowing a user profile and sharing it is, how is that going to happen?
Yes, yeah, both are really important questions, insightful questions. Thank you. On the first question, that openness interoperability, to begin with, it's a distributed systems problem. It's a problem in distributed systems that is, to a great extent, solved when a person is interacting with one system, say it's still, say, Yahoo or Google. Let's start there. But they're using mobile phone, then their car interface, home machine, work machine, still with the same platform. How does the interoperability work? That because there are central servers and data centers that are capturing those signatures about the same user. There are tracking pixels and cookies and measure, identity, means of that nature to integrate all of that and still count it as it is the same user. Now, how do you deal with that interoperability if there are multiple systems, meaning the user is interacting part of the time with Google, but then, or Microsoft, Bing, say, and other time with LinkedIn, which is their partner, and on another day with Facebook, which is their data vendor. And these platforms purchase these kinds of data about users and their behavior from multiple different platforms like that. There, how does interoperability work? And how do you figure out? In healthcare, my team built platforms of this nature for healthcare industry prior to my current role. And there, record linkage is a big, huge problem. That, to emphasize how complicated it is, the question that you're raising, say, John Smith, that is a patient in the system among millions and millions of electronic health records. J.E. Smith, John, J-O-N Smith, J-O-H-N Smith, Smith, comma, J-E. These are all potentially the same person or not. How do you figure that out? That is called probabilistic record linkage, the EMPI, Enterprise Master Patient Index. There was $1 million prize, if I recall it correctly, to crack just that one problem. You see, so definitively, how do you know that this is this person, or you are depersonalization, upsetting that person, right? And then privacy. Luckily, even as difficult as it sounds, everything that in my answer so far is a technology-focused problem. We can do something about it. Now, when it goes to privacy, for very good reasons, there are grave concerns from people, governments, and agencies about what these systems are collecting about us, what can be used, what cannot be used. California leading, there are privacy laws that are being enacted. So it is to listen to legal advice and get consent from the consumers as much as we can, and being really careful about what is it that you can purchase, collect, and use in your query log analysis and personalization, PUPs, the personalized user profiles. What is it that you could do? We need to take that care to comply with privacy regulations.
So if I want to get hold of my personalized user profile, how would I go about that? Can I purchase it from someone?
Yes. There are increasingly companies, vendors that are emerging for that. There is a company that is myreputation.com, somethingreputation.com, you see. And they constructed metrics for your web reputation, and you could work with them to get reports on your reputation, for example, and about your own personalized user profile and what the company is using, whether you can request the particular platform to give you your user profile. That is a new question to me. That what law says about it, I do not know. With governments, we know. Like the governments let us, as citizens, to right to information in different countries. You know, that is there. But do we have right to information with individual corporations? And can we ask for our PUPs from different platforms? This is a question to which I'll have to look up the answer. I do not know.
Hi, thanks for the talk. My question is around how do you measure success both in personalization as well as in search case? You showed some metrics. One was in the NDCG, which you said, hey, this is one of the ways to do it for search, and here you're showing MRR. My question is, how do the more traditional metrics of precision and recall intersect with NDCG and MRR?
All right. Yes. So first of all, MRR is the mean reciprocal rank. That's what it is. It's helpful to understand that when the search engine is returning search results to us, if the user clicked on the very top, the number 1 link, and they're satisfied, that means they're satisfied with that, then the reciprocal rank is 1. If they click the second entry, then it is 1 by 2. If they clicked on the third one, it is 1 by 3. So on average, from your search engine's performance, what is the average rank across all queries? This is MRR. That is, the higher that number is, the better your engine is performing. Same metric for both search engines with personalization, search engines without personalization. To see what is the proof or validation metric for search, personalized or not, is a few things. The user clicked on what is being presented prominently. Then they looked for that item repeatedly. This happens quite a bit. We'll click it, then we leave it. We don't right away buy that. And we then go back and look for it one more time, one more time. So that is captured as a metric. And finally, did they actually buy it? Did they buy it again? So you can construct a composite metric, and hit rate, of course, beyond MRR, just are they clicking the links or not. So these are the metrics associated with discoverability and search. Then on the previous slide, there is what is called alpha beta discoverability. That is, if displays of all items, this is from the seller's or the producer's point of view. I'm keeping these items in the catalog, how discoverable this item is, right? So for platforms, for any contract to work, both parties need to be satisfied, right? So that is it. There are relations between these metrics and precision recall. There's a math associated with that. In the interest of time, I need to pause here.
Okay, thank you so much, Prasad, for an excellent talk.